From the outset, I have been in agony with my top jaw around my front teeth. It is like having a vice between the two implants here. This pressure then presses down into the very, very roof, into the nerves and the roof of my mouth.
It took 3 years to diagnose the reason for the intense pain in the centre of my top jaw. By making a temporary upper bridge in 2 parts, the misalignment was identified. The right front centre abutment and screw did not line up with the implant in the bone. This pull-apart tension between the rear and front implants eventually pulled the front one free. If the implant fixtures and abutments are slightly out of alignment, then screwed in by force, horizontal tension occurs between the fixtures. The bone has to carry the impact tension of this, stretching or compressing the bone. There's no way to tell if the horizontal adjustment is correct once bridge teeth are inserted, only by the pain of the patient.
Okay, so if we have a look at the fundamental structure of how implants are put in, I'm doing this on the flat and I've just built this out of plaster. If we imagine that this is actually the gum, obviously it's not level. We've had teeth that have been taken out, which has left, different levels of your gum. There are no nerves left because all the nerves have been in your teeth, and therefore it's numb. This gum is actually numb. So they then drill holes in the bone, subject to where the bone is, and these implants are then inserted into the bone, and then you have to wait for 3 to 4 months for the bone to grow around these implants so that they're going to be solid, fixed and stable. What then happens is that if you remember, you have the curved thing with these built in into the metal, and here I have just done it on the flat. These are the abutments that are on the flat. They then have to be aligned up and screwed in to these implants. I was told that the testing of the vertical tension between the bone, the implants and the bar is made quite unscientifically, but simply by screwing one down very, very, very tightly. Then if there's movement this side, it means that this might have to be loosened. This is the only way that it can be judged about the tightness or the tension of this metal bar.
If the screws are tightened in uniformly into the implant fixtures, it forces the rigid horizontal bar to try and bend. But because the metal is rigid, the forced tension is held in the more flexible bone of the jaw. This can create a feeling of push or pull within the bone, which puts it under constant tension. Height adjustment is made by adjusting the level at which the screw is tightened into the implant fixture in the bone. This is judged by sight and wiggling the bar by the prosthodontist to find the correct level. Final judgment is made by the feeling feedback of the patient.
So the vertical alignment between this and the teeth can be adjusted by adjusting the height of the screw within the implant and within the abutment itself. However, what can't be seen or judged is the horizontal tension between the two screws. There's no way of telling whether these two screws are pulling this metal bar together or pulling it apart. There's just no way to tell, except by the patient's own experience.
I have subsequently been told that if this happens, it means there is a design flaw.
In this model, I've included 2 angled implants because in my mouth these angled implants were placed in. So the idea is that I've got a straight screw. It goes through perhaps slightly angled abutment, which then has to go into an angled implant underneath. And supposedly it increases the strength of the bridge itself, but the potential then to create this horizontal vice-like feeling between these 2 screws can be exacerbated. A slight 1 millimetre difference in height, 1 millimetre difference between these screws, because this metal is so rigid and the abutments are also rigid, the place where the tension is going to be felt and created is in the bone itself. And this metal rigid top is actually pulling my bone in together, and therefore the bone is continuously under pressure. So while engineers know that when building a bridge over land, they have to make allowances for the change in the landscape underneath, perhaps the deterioration, shrinkage or movement, they do need to build really, really solid foundations, something that's going to support this metal structure that is going to have traffic over it. In order to do that, it's really important then to allow for this metal to have some sort of movement so that the strain or the impact is not going to be felt on the land underneath. Because if the land moves and this foundation moves, then the potential is for this bridge to fall apart. So they are likely to allow for pressure here, up and down. So that's your vertical pressure, whether it's weight or wind, and therefore they will put the ability for this pylon or this structure to have some kind of movement, perhaps above and below the solid metal framework. Similarly, they are going to need to have some kind of movement allowance between these foundations. So they need for this very, very slight movement in the solid top framework to allow these to remain solid. These principles of movement and stability are not used in the bridges in our mouths. The strain then for any movement, whether it's this when we bite together, or this when we move our mouths, or our jaws try to move, this doesn't. The only way then, if these pylons or these supports needed to move, they're going to be felt in, and the movement is going to be transferred into the bone, which can cause deterioration. I can tell you it certainly causes tension within the bone, which is why the bone can feel as though it's in a constant vice, because it is the rigidity of this metal transferred through the rigidity of the metal here with absolutely no give, and that impact, that energy has to go somewhere. So it's going to go in here. The potential then is for the bone to give way. For anyone who's ever put a wall plug into a wall into masonry, you know that you have to drill the hole and then this becomes the plug. You can think of this in the same way as inserting an implant into a bone. When you first put the screw into a plug, you screw it in, and the inside of the plug then follows the pattern of the thread of the screw. If ever this becomes loose and you decide that you want to use a different size or a different type of screw, what happens is that you can end up with problems because the inside of this plug is already aligned to the thread of the previous screw. So it's really important to have the same screws that match the original implants. Now I have to tell you that my implants didn't fail.
The constant tension finally took its toll, and the screws in the abutments failed, leaving the top bridge held in by a single screw. The teeth are nearly out. The front has come disconnected altogether. The two back ones are being held on by a thread. With the thread stripped and the abutments fallen out, the outcome was a top denture after the whole bridge was only held in by one connection.